Hello, everyone, and welcome to the VaNTAGe seminar. Today, we're ending our series of talks on machine learning and number theory, and we're very happy to end this series with a panel on mathematics, and AI. So, I want to thank again our panelists who are joining us today: Jeremy Avigad, Jennifer Johnson-Leung, Jacob Tsimerman, and Ravi Vakil. And to all of you also for agreeing to record this panel. And for the audience, we're going to go through a series of questions to the panelists, and then there'll be a time at the end if you want to follow up or ask any questions of your own. So so let's get started. As you briefly introduce yourselves, the four of you, can you explain what frontier of AI, whether it's large language models, automated theorem provers like Lean or machine learning, convinced you that this conversation was too important to skip? Jeremy, do you want to
Yep,
go ahead?
I'm happy to start. Yeah, so my name is Jeremy Avigad. I'm at Carnegie Mellon University. My primary appointment is actually in the Department of Philosophy, but I have a secondary appointment in the Department of Mathematical Sciences. I have been I started using proof assistants in the late 1990s. So I've had a longstanding interest in formalization of mathematics and automated reasoning, so what computer scientists call formal methods. And in the last few years, the excitement of AI has carried over to AI for mathematics, which interacts with formal methods a lot. So for me, I think it's all the technology. So I think all of them hold a lot of promise for mathematics. Also, a lot of them bring anxiety. Each of the technologies on their own holds promise for contributing to mathematics. But I think it's also interesting the synergies and interactions between them. So I think it's really it's the basket of technologies all happening at once that we really now need to think about and deal with.
Wonderful. Jennifer?
Yeah, so I'm Jennifer Johnson-Leung. I'm a math professor at the University of Idaho. And I think I became really interested in um, the machine learning technologies when I first went to a talk on the structure of transformers and just became kind of fascinated by what is the sort of geometry of the space of ideas, right? These embedded latent representations. But in terms of this conversation, I think what's really caused me to engage both in our AI literacy efforts at our institution and then thinking about the applications to math more broadly is that this technology, especially the LLMs as they're instantiated now, are generative. And so they're creating things in our spaces and in our intellectual repositories. And we can make decisions just like if you're planting a garden and you want to grow it, you make decisions about the landscape architecture, you build trellises that you want things to grow on, you choose seeds to plant. I think that those are decisions we can make right now that will have a big impact on what the mathematical ecosystem augmented by AI looks like. And so I think it's important for us to engage.
Thank you. Jacob?
Yeah, I'm Jacob Tsimerman. I'm a professor of mathematics at the University of Toronto, though I'm at Princeton at the Institute for Advanced Studies for the year for a special program. I basically think that I've been following the AI space for a long time. I've had friends who were very prescient about what we're going through now. I've been much slower on the uptake than them, but for the past few years, I've been convinced AI is going to be a very big deal. It's going to enter our space and change it substantially with capabilities input from these AI systems. And I think that the community isn't, even though we're having all these panels, which is great, I sense that there is an inadequate reaction to the size of this change. And I think that we have to think a lot more about how our space, our community, our professional community has to change if it's going to survive what's coming.
Thank you. And Ravi?
Great. I'm Ravi Vakil, and I'm an algebraic geometer at Stanford. I've been somewhat randomly involved in a number of different aspects, benchmarks, research with proprietary models, formalization projects, and so forth. But I guess I feel like I'm a charlatan being here, and that I'm not an expert, but I'm also aware that almost all of us are novices, and it's important for us to be engaged because, as Jacob said, the change is coming massively, and as Jennifer said, we have to really think about planning the future, even if we're not sure what's coming. Also, by accident of currently being president of the American Mathematical Society, I've had no choice but to see how the developments have impacted many aspects of mathematics and profession, including education and publishing as well. So I think transformation is coming. I think it's really the uncertainty and the error bars are large, but that doesn't mean we should. I think historically we tend to sit back as mathematicians and mathematics in general, sit back and just watch things happen and watch the future pass us by. And I'm happy that we don't seem to be doing that this time. That we seem to at least want to attempt to be involved in deciding what the future looks like.
Thank you. So the one question that all four panelists definitely wanted to talk about today was one about concerns. And so let's just get right into it and talk about what is your greatest concern about how AI is changing research and teaching in math, and what do you think the math community can do to mitigate this concern? Anyone want to go first?
So I can start. So let me start by saying that before we talk about concerns, that for the most part, I'm optimistic. I think the technologies are pretty amazing, and as I said, they hold a lot of promise. They will let us, do things that we could not do before, and so I think overall, that's a good thing. But I do have a lot of anxiety, and at least three different concerns. So the first is that uh, as Jacob says, I think AI is going to change mathematics and the way we do mathematics. And one concern is that if mathematicians don't react quickly enough, that mathematics may be sidelined. I mean, what we're seeing now is that AI is getting really good at doing a lot of things that we used to think that this is what we do as mathematicians. So we're good at solving hard problems and proving hard theorems and constructing these very long chains of very delicate arguments. And we're starting to see AI get good at that. But we also, pride ourselves on our intuition and our insight from experience. We've read the literature, we have sort of a good feel for mathematics. But AI can now kind of synthesize and crawl the archive. It's read every yellow Springer book on your shelf and so on, and so it can detect patterns and so on. And so the question is, what role is going to be left for mathematics? I think there's sort of one model that mathematicians just we wait for the technology to get better, and then we just start you know calling Gemini and asking it to prove our theorems and so on. I think that's kind of a horrible vision for mathematics. It doesn't leave much room for mathematicians. I think that the positive way out is that we've got to learn how to use AI to do all the things that we've been doing all along, but do it better. To build theories, to solve hard problems. And I don't know exactly what that means, but it means sort of engaging with the technology in ways that I think will change, what it means to do mathematics. I mean, I think, mathematics going forward will be more empirical and involve interacting with AI systems as we explore, the mathematical universe and, look for intuitions. And so, yeah, I think we really need to get going on that. The other two things I'll just throw out there that maybe we can circle back to are I worry about access. I mean, even now, a lot of us are experimenting with Gemini, and so those of us who are willing to pay, the $100 a month, $200 a month, and so on. And so, it can get expensive, and there's the concern that that to do the cutting edge mathematics, you'll need to be spending money, and where that's going to come from, and how that's going to shape the discipline. And I also have concerns about just the environmental effects of AI. So I think, I mean, this is not, restricted to mathematics in general, but insofar as mathematicians are going to use AI, we should be mindful of the environmental effects.
Thank you. Ravi, do you want to continue here?
Sure. I guess I should preface by saying I'm also like Jeremy. I'm optimistic, even though we're starting with concerns. But I will admit that I always try hard to see the glass as half full and to try to look for opportunities. So perhaps one could say everything I say in a more negative way as well. So I agree with the concern Jeremy said here. So the three things that were on my mind as concerns were first, I think that there's going to be a threat to learning the vast majority, well, for a significant majority of people, depending on their intestinal fortitude. I think that's going to be all the way from young kids all the way to graduate students in how we do research. I think the best or the most motivated or the wisest will be accelerated vastly, and I think others will. There's good reasons why they'll start to learn how to think less well or not learn how to think well. And this leads to this can go many ways. But what I really fear, and what I think many people aren't seeing, is a great danger that AI is going to be used as a Trojan horse. I think a poorly disguised Trojan horse and an excuse for attacks on and deep cuts in basic research and education and generally anti-intellectualism. That people will use it as an explanation for things they wanted to do otherwise, for things that are happening in society that are not really caused by AI. And I think mathematics and science in general are going to be very vulnerable to these sorts of attacks. That we no longer need people to understand how to think mathematically or scientifically because they could just ask a model. And I feel like the lack of trust in the experts has already led us to some dark places. And I guess the third thing is I'm less worried about, to get into things that are much more to do with our profession. I'm much less worried about than others about things like assessment, including about hirings. I think tentatively we as a community can be okay with that, but I think our model of publishing is going to experience some massive disruption, and I don't know what's going to happen, and I see problems, and I don't know so I don't even know what it's going to look like. I don't know exactly what the solutions are, but we'll have to figure it out on the fly.
Yeah, thank you. And Jennifer?
Yeah, so I think mathematics interacts especially with these LLMs in two sides, right? I mean, they're using and sort of developing new mathematics to explain and interpret what's happening inside of these models. But then these models are also using mathematics as benchmarks for how well can they think and how reliable are they and so on. And I think I have a lot of concerns outside of the mathematics specific direction. But I think in terms of mathematics, that's what I worry about. I worry about AI sort of steamrolling us over and leaving us sort of smashed in the dust. And I don't think that's inevitable. Um, to me, mathematics is fundamentally not about what's true and it being true out there. It's about what we understand is true. I think mathematics is something about human knowledge and human understanding of these facts and the reasons for them. And I think preserving that is going to be something that is going to be challenging and is a challenge worth taking on, right? So, what do I mean by that? You could imagine that there is some proof produced by, say, Opus of the Riemann hypothesis that no one can understand, that is, garbled in interesting logic and some weird formal proof somewhere underneath. And there's something there, but we don't really unpack or understand anything more. Is that any better than what we have now? I mean, to me, it's not really. We have enough computational evidence that I would say that's just as good as a proof that is incomprehensible to all people. So I think preserving mathematics as sort of a humanistic discipline is, I think, one of the bigger challenges to us with this technology. And how does that technology support us as mathematicians? I think this is leading on top of what Ravi and Jeremy were saying, but I've been thinking in terms of these, what the chess people call them, centaur systems, right? So you have your chess master and your chess engine working together to do things that would never have happened before. And I wonder to what extent we can think of ourselves as centaur systems. But this begs another question that they brought up, a second really big concern, both in mathematics and I think in technical disciplines broadly, which is also related to the education piece of how do we onboard junior people? I mean, traditionally, people work on simpler problems, things that you might give a student something you already know how to solve, but you haven't written down yet, right? I mean, the AI could reasonably be expected to be able to do these problems, right? Same thing for junior developers, or in any field, really. Like you become familiar with the social norms, the cultural norms, the important questions by working on fairly simple tasks. So, what are those onboarding procedures going to be in the future? How do we think about training up our junior colleagues?
I agree. I think we don't even know how we should be teaching calculus anymore.
Mhm. Yeah, thank you. And Jacob?
Yeah, I agree with a lot of what's been said. I agree with Jennifer. I want to echo her that like my main concerns are outside of mathematics, but we're sticking to mathematics, so let's focus there. Within mathematics, my biggest concern by far is that we're not preparing adequately for the fact that AI systems, uh, I think, are very likely to exceed capabilities of human mathematicians, and our role as mainly like theorem provers or theory builders, discoverers of truth, however you want to call it, is going to have to shift. And I feel like it's going to happen very suddenly. And so I would like to see, well, my concern is we're not transitioning appropriately into what we should be in the future in the sense of like a professional endeavor. So mathematics as a hobby, mathematics as a practice, people doing mathematics is going to continue, and it's probably going to be better in various ways because we're going to have these AI systems to help us. The question in my mind is, do we continue as a professional endeavor? Is there room for that? Should there be room for that? What does that look like? Is it more of a sort of appreciation social club? Is there a humanistic component to it? Um, yeah, and I think that I'm sort of worried, I guess, of us missing the forest for the trees. I think there are all these questions. I think I'm sort of the opposite of Ravi in some sense, where we've become nemesis. Ravi is worried that we're too concerned about a lurking forest which never comes to deal with all these important trees like funding and training and hiring, which are really important, short to medium term questions. And I'm concerned that, well, we're doing all that to save a ship which, if not sinking, is at the very least transitioning to something. And if we don't envision what that is, we're going to be caught very much off guard.
So I have a
Well,
question,
that,
Jacob. Do you think that the models are going to really be able to theory build in the short term and to draw connections between objects that are really quite far apart from each other? I mean, when you think about the sort of linearization of these ideas, I mean, do you have good reasons to think that that's possible without also human in the loop, sort of stimulating some of those connections?
Yeah, good reason merited discussion, like an argument. So, I don't think we have time to argue, but yes, my beliefs. And yes, I think they'll be strictly better than humans by a large margin at problem solving and theory building and, explaining basically everything under the sun. You actually brought up centaurs as an analogy, and centaurs don't exist anymore because the best thing that a human AI chess team can do is listen to the AI and get rid of the human. I expect something similar to happen very shortly with math.
Yeah, I mean, Jennifer, in particular, in terms of, when we think of things like, detecting patterns, seeing commonalities across different branches of mathematics and finding connections and coming up with interesting generalizations, I see no reason to think that AI won't be able to do that. Like I said, it's read every math textbook out there. It's sees the archive, and AI is good at things like that. It's good at synthesizing lots and lots of data.
right. Well, building on this word envision that Jacob talked about, I mean, are there things that we could feel optimistic or confident that AI could help us tackle? I mean, are there ways that we could be ambitious and improve mathematics or improve the community of mathematicians in a way that might not have been possible a few years ago?
I
Anyone want to
think
go
it could help
first?
us draw connections,
Mhm.
to sort of, you think about mathematics as a field having gotten so broad, and also so deep in different specific areas that it's very difficult sometimes for to talk to each other, to even talk to people in your own department about what it is that they're working on because it feels so far from what you do. I think these tools could help to shrink that again, to help us understand one another better and to bring near field mathematics that you might have felt uncomfortable trying to use to be something that actually you can grab onto and use and feel confident.
Yeah, I think if I could jump in, I think that I agree with Jennifer said very much, and I also think that there's a skill in learning to use these AI systems, and sometimes it's specific to which AI system you're using, and so it changes every 6 months. But I think there's a more valuable sort of generalizable, robust skill of learning and using a system that is much more capable than you, at least in some domains, even for now. So I've had the experience of using systems like Cloud Code and ChatGPT quite a bit now. And one thing, especially when using Cloud Code, is that it will do a lot more for you than you know what to do with. And sometimes what it does is bad, and you have to figure out that it's bad. And sometimes it's great, but you don't have time to figure out what's going on. So I think it's similar with math. I think we should be encouraging people to use these systems to learn, if not to reason, with the problem solvings, because it builds the skill of you now have this tremendous flood of information. How do you figure out which of it is useful, which of it isn't? How do you figure out what you actually wanted, what you didn't want? What do you even do with somebody that can give you like 100 pages on exactly what you wanted from various perspectives when you can't actually read and digest every single page? I think those skills are going to be good more broadly for mathematics and in the general world.
Yeah, I mean, I raised the concern of access, but in a way, AI does open up access. I mean, any of us can sit down and with any of the big tech models and ask for a tutorial on any topic at all, right? And then, if we don't understand, ask for more information. And so, I mean, this is school, and anybody with an internet connection, and again, with enough money to pay for the subscription, right? But can start engaging with mathematics and asking questions and getting feedback. And again, it used to be that the feedback was nonsense, but now the feedback is really getting substantial. So it does open up opportunities for more people to engage with mathematics. The the question is, will they, and how do we want them to engage in mathematics? But at least the potential is there.
There's also a chance for some shift of the culture, right? In the sense of, these models are extremely sycophantic. Like my ideas are so good. I've never had such good ideas in my whole life. And that's not the culture of mathematics. I mean, you're used to interacting with mathematicians. You say something you're excited about, and people go, maybe.
Yeah.
So I think there's things like that that will have effect on how we interact and how we think about our own work that we need to be cognizant of and kind of.
So I think this is a good thing or a bad thing. I mean, it goes both ways, right?
I think it
Sometimes
can go both
encouragement is
ways,
good.
but I think that
Yeah.
you need to be aware that, if you're talking to to Claude about your mathematical ideas, you might not get the skepticism that you would expect from like your neighbor in the hall.
Yeah.
Ravi, did you want to add anything?
I sure. I think I agree with the points made so far. I think that the culture is going to change, and I feel like I have a hard time speculating on how it's going to change. But it's interesting to see as people experiment and to try things out. That one thing that seems to happen is people talk to models and they say things that are nonsense because they themselves haven't understood it themselves, and then they get a very different reaction from colleagues than they do from the model, which told them that they were geniuses. But this is, I think, a very limited. I think, as Jacob said, things are changing very quickly, and so in 1 year's time, the story may look very different. But I still think whether the quality of human understanding, which is central to what we do as mathematicians, some humans are going to be able to understand better by talking to models, by developing good practices of learning, and others will not. Yeah.
I just add a very quick point, or we have to move on, Rachel.
Yeah, no, go
Okay,
definitely.
just very quickly, I very much agree with what Jennifer said about sycophancy. I think it's a huge concern at the moment. I mean, things are changing, but people have to learn how to keep a level head. And I think Ravi was saying the same thing with education. I do want to not push back, but I want to say one other thing that I've noticed here is sycophancy is its own thing, but there's something very nice in talking to the model sometimes. And I think that comes from being understood. Like one thing we want in, romantic relationships, mathematical relationships, friendships, is for the other side to really get what you're saying. And it does feel super good when you tell the AI something, even if it's wrong. And it's like, great, you're confused about exactly the right thing. And then it tells you what you're confused about, and it is exactly the right thing. I think it's
Mhm.
important to distinguish that from sycophancy and somehow think about it differently.
Yeah. Again, I've gotten great explanations from AI. It can be really helpful.
Mhm.
Yeah. I think it's super helpful for like organizing my thoughts. If I have a whole bunch of jumping around ideas, I can just kind of put them in the model in whatever order I want almost and like change subjects um and it somehow coheres back into, with the back and forth, like a somewhat organized idea. And that's at least the way my brain works, that's been a very helpful thing. Because often if you're trying to just write it down on paper, these you get frustrated, at least I get frustrated with myself with the jumping around, right? And the model doesn't seem to care. And then I can get it all out.
Well, we have a lot of young people, junior mathematicians on this call, and I wonder if you could give, advice to them about of what steps to take next. Is mastery of formal verification or statistical machine learning an important step for every graduate student to take? How would you recommend graduate students develop themselves at this time?
I think the answer is yes. I mean, I think if you're a graduate student in mathematics today, you should be learning about the new technologies that are out there and what they can do, and thinking about how they relate to your mathematical lives and your mathematical careers. And I think we should all be figuring out what the technologies can do and how we should be taking advantage of them.
Yeah, I mean, I'll add to that. I think thinking of these technologies as tools and mastering the tools is essential for graduate students. I don't know that, you know, understanding the details of rewrite systems or, like becoming an expert in statistics is necessary, right? You need to be able to use the tools um, and to understand what the limits are. I mean, some people may become interested in those things as well, right? But I think that again, with the AI models getting so much better, so much faster, you're not going to have to be a lean wizard in order to get a formal verification of your results. You're just going to have to learn how to use the interfaces and know something about what formal verification is, like what's actually happening there.
I think I think my yeah, I think my only quibble with the question is the word every in that statement. That every
Mhm.
uh, that I really don't think anything applies to every graduate student. I
Okay.
think well, the one thing which does apply to every I think is don't be afraid and don't be rigid and don't be religious about your fear of new technology. I would say if you're not someone who experiments and who's curious about new things, then probably in some sense mathematics is not right for you because mathematics is this is fundamentally what being a mathematician is about. But now you have to be curious and willing to try new things. But if you're someone who loves lean and would find that fascinating, then you should go deep and jump right in. And if you're someone for whom you don't want to, I don't think most students need to know, as Jennifer
Yeah.
said. So you needn't. There's not a must. There's not a other than don't avoid it and experiment and don't try to be a 19th century mathematician because you're tying your hands behind your back. I think
Yeah.
in some sense it's similar to what came before, except now you should experiment. Ideally, experiment as much as you're able to and follow your interests and go deep as much as you can.
Yeah, let me qualify what I said before. I wasn't suggesting that everybody should, be experts in all the technologies or use all the
Yeah,
technologies.
of
I
course,
think every
right.
graduate student needs to be aware what's out there and then has to make mindful decisions about what they really need to dive into more deeply and how they need to, how they should use and engage with the technology.
Yeah, I definitely agree that advice should be used appropriately. And, we are all amateurs, as Ravi said. in some serious way. And in general, people know themselves better than everybody else. So don't change what you're doing because you heard something on a Zoom call. Having said that, the advice I would give and do give is to use AI as much as you can. Sort of, I would go out of your way to um, find a way to make AI fit into your workflow, into your research, because that will prepare you better for dealing with the changes that are coming. I mean, I think there's very little skepticism even on this call between everybody, even though there's a lot of disagreement. There's very little skepticism that AI is going to make a big impact on mathematics in some way. The extent is debated and the way to look is debated, but it seems like a good bet that it's going to be something that's good to keep an eye on. So I would say put it in your workflow, and I would go further in line with my first answer about concerns, and try to see if you can carve out a research field, a space in the department which blends math and AI together, whether that
Yeah.
involves, studying how to dissect AI answers or just answers in general and expose them to the math community better, whether that involves figuring out how to interact with the systems better through queries or through mutual projects for now. I would say that those things are good. Echoing Ravi that, not everyone should do everything. I think that that's a good place to lean.
Yeah, if I could, because this theme comes up, this often comes up in conversations with colleagues. When we think about, what kind of expertise we need with technologies, I mean, there's kind of two extremes. One extreme is that we just need to know how to use it, right? So in other words, Google, uh, 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 you know, again, Google Gemini will get better, and we just need to know how to type in the questions, and it's going to then prove our theorems. So we're just kind of users, and we're just learning how to use the technology. At the other extreme, there's like, well, we need to be more like computer scientists. We need to be developing the technology. We need to be training models and writing proof assistants and writing automations, become experts in rewrite systems and so on. And I think neither one is right. I think there's kind of a middle whereas, I think there's a fine line between using and developing when you figure out how to use AI to solve particular types of mathematical problems or to do mathematical research or to explore or answer questions, I think we do need kind of sustained thought and exploration and figuring out how to use the tools effectively and how to adapt the tools. And maybe it's collaborations with computer scientists in part. But I think there's this, I mean, somewhere between, using and developing, there's I think that's going to translate to doing mathematics. Doing mathematics will involve, learning how to push the technologies and bend it and shape it to do interesting things. And it's that space in the middle that we have to find. We don't want to all become computer scientists. Computer scientists are very good at what they do, and mathematics is different, right? That's not what we want to become. Um, but I think there's an equally kind of deep and thoughtful and involved process in mathematics for figuring out how to use the technologies. And I think that's what we have to aim for.
So I'm curious, when you talk with what Jacob was saying about a student kind of integrating the AI into their workflow, which I don't object to, but I also don't really feel confident in how to advise that. Because if you think back, 10, 20 years ago, you have students who get very involved in developing mathematical software as part of their PhD, and then maybe have a hard time having that valued by the community in the same way as like a traditional theorem. Um, I think it's a challenge, and I don't have a good answer for that, but I'm curious. I have a student who's getting ready to start on some work, and I'm a little conflicted right now in terms of how to advise them to engage with AI. Like I feel like I'm getting a good idea of a workflow for a working mathematician, although I still have some collaborations that no AI has touched that because that's not something that my collaborators there are comfortable with, and others where I'm engaging, with the tools more broadly. Um, this is not me. I'm supposed to have answers right now. This is me asking questions.
No, I agree with you. There's a tension there. And I think, there's a world one can imagine. I don't think this is our world, but there's a world where AI kind of never gets better at math, say, like it's as good as it is right now and it never improves. And in that world, if you currently spend your PhD and your early research years writing papers that are like, look, I did something cool with Claude or with ChatGPT or Gemini or whatever, I think your work is likely to be devalued by many people. I'm not saying what should happen. This is not an opinion, but in my estimation, many people will look at that and say, well, you aren't a real mathematician. You're not really doing math work. You're using the systems. There's a world that I think is more likely where AI does change the world a lot. And then if you just prove some cool theorems, which are impressive from our current standpoint right now, people will say, well, who cares? AI is better than you at math. Why are you spending your time doing this? So I think it's a real tension, Jennifer, that I think it's a real tension you're asking about. I think that the smallest, like clearly positive amount is get good at talking to the AI about math and using it to help you in your research. Use it to get up to speed on existing literature faster and background faster. Use it to write your LaTeX files. Use it to sort of test out arguments. Figure out as best as you can how to use it in your existing research. I think that's the smallest minimal amount of like definitely do this. And beyond that, I think it is a bet. I don't have like a here's the best of both worlds answer.
Mhm.
And the only thing I would add to the points which I agree with that have been made so far is that I also that the goal is not for us. We should not think that we should be telling our students how best way to use. Well, maybe people who are experienced, more experienced than me should, but really the experimenting should be also done by the students. I think encouraging them to try it, and they're not all going to do it the best way, but I feel fairly confident that the best people whenever it's a metaphor, it's not the same thing, but in any field of mathematics, the the best practitioners always end up being the young people who come natively to it and develop their thinking in it rather than the older people who learn it as a second language. So I have the advantage that my students often know many different things that I do and I'm ignorant of them, so I'm used to sending them on their way. And I think but that's what I think we should feel comfortable encouraging them as I think the other panelists have been suggesting, to go and do things. And maybe we have some ideas to what might work, but they're as likely to tell us something or tell me something about how best to use it than the other. And in particular, there's a lot of calls. There are really calls in a big way to, for example, there should be high school courses where on AI, where or undergrad, maybe some math classes, maybe in undergrad we should have courses teaching students how to use AI. And this just seems idiotic to me because I don't think that I should be teaching students how to use
Sure.
AI when I suspect the students themselves are much better at it than I am. And the idea that there's any sort of curriculum that we should be making at this point in planning, because of course it takes years in advance to plan such a curriculum, just seems absolutely idiotic.
Yeah, no, I think our obligation as more senior members of the community is to figure out how to open up a space for young people to do that. So Jennifer, I'm very mindful of the fact that, if students invest a lot of time in really learning the technology well and doing unusual and novel things with it, that's a lot of time that they're not spending, doing conventional math and writing conventional math papers. And then when they start looking for jobs, they don't look good on the conventional measures. They've done a lot of other interesting things, but they don't look good by conventional measures, and they will suffer because of it. I think that's why it's important that we have discussions like this. As a community, we need to think about what types of activities we should encourage in the next generation, and how we're going to value it and assess it and encourage it. And so part of it thinking it does require coming up with a vision of what mathematics is going to be, and then figuring out how we can set up the incentive structures so that so again that the next generation can opening up a space for the next generation to get there.
Thank you. Maybe we could circle back to this concerns raised earlier about challenging to preserve human understanding, which Jennifer mentioned, and Ravi's the concern about anti-intellectualism and threat to learning. What do we need to do to bring, as mathematicians, to bring a wider community of people, on board with mathematics?
So can I just clarify? Because I think there were two separate
I,
things
I,
that you
I was
might
about to
Oh,
say the same thing.
there's
okay.
the
Well,
question
I
there's the
I guess
question of
one
like
question is about challenging to preserve human just teaching, I think really about teaching. And then the other was about well, why don't we just stick with challenging to preserve human understanding first?
So the concern is like students sort of using the AI systems at the expense of their own understanding. Is that correct?
Yeah,
Yeah.
yeah, and we
Yeah.
also had a question about, cognitive risks.
Yeah. So did
Have
you
you?
guys see there was a study that Anthropic did, a small study on their own developers where they had them use a new Python library and they were randomly assigned to either use AI support or not. And then they had a test at the end on what the library did. And certainly the people who did not use AI support did better than those who did on the test at the end. They understood better. But if you drill down a little further into the study, um, it depended a lot on how they used it. So the people who were using the models to explain what the function does and to discuss the library and to make sure that they were using it correctly actually did better as well. And then the people who were just using the model to do the coding for them did
Mhm.
not understand what the library had done. And I think so all of this is to say that this is not about the tools, this is about the practice. And I think that we need to establish norms and we need to be open and discuss it. I think we need norms for how did we use AI? I mean, I wrote a proposal recently and I crafted a prompt where every time I finished using the model, I said, this is my AI disclosure statement. Is it still correct? Right? What else, what else did you do? What else is yours? Right? And I mean, I don't know, that's just, and then I put the prompt in the disclosure as well. But I mean, I just made that up, but I think we need norms
Mhm.
that say how we're using these tools and for ourselves as well, right? We are really good at deceiving ourselves. Um, so to be maybe mathematicians are less good at deceiving themselves, but I think humans in general are pretty good at deceiving ourselves. Um, I think this is also maybe we'll get to journals later, but I think it's related to journals as well. And I don't think we know what the answers are. I would love to see us have some experiments, some pilot studies where we keep track of data and do sort of the Carl Bergstrom style, like economics of incentives, to see how it affects the practice and be open to adjusting to get the results that we want for the community.
Mhm.
I don't know if that answered the question at all,
Yeah,
but
thank you. Anyone else want to add anything?
I think I disagree a little bit with the
Mhm.
question, the premise of the question, I guess. So I agree. I think there's two things that were touched on in Jennifer's answer and some other answers. One of which is like testing, whether it's testing students' abilities, whether it's checking for publications, how much AI was used and not. That's sort of a separate question in my mind, is discovering authenticity. Just about the question of AI impeding learning by virtue of students overly relying on it. So I think this concern is overblown. I think that various uses of aids could always impede learning. This happens with courses all the time. Like students will do homework questions against all advice with the book open, even
Mhm.
before AI, and they get the questions right, and then they go to the exam and they don't have the book anymore, and they don't get them right anymore, and they're surprised. So, like in my courses, consistently when I have a midterm, students do way better. And consistently, the reason is that after the midterm, students are like, oh my God, turns out I don't do as well without the book. So, there's this skill of just like, can you test your own understanding? Are you fooling yourself? That I think some humans learn and some don't. And the ones that don't usually also kind of know, but don't really care very much. Like a lot of our students who cheat to various extents just don't care about knowing the material and are following local incentives, I think. I think there is some concern about like potentially about people thinking they understand more than they do. But I just don't think it's such a big problem. Like if you learn something from the AI and you want to test, do you know it? Just turn the AI off and try to do it yourself. I mean, I
Mhm.
suppose some people don't have discipline to ever do that in any context. But if you're engaged in a professional endeavor where you learn to actually value feedback, then then I think it becomes common practice. So I'm not sure this is something we should be focusing on as a community, I guess.
I mean, I think we can make the question more concrete and factor it into two parts. I mean, one question is what is the so look, learning and understanding requires work. So if tools are just making us lazy or making students lazy, then that's not a good thing. But one thing we have to think about is, well, again, given the new technologies out there, what are the types of understandings that we want students to have? What do we want them to be able to do? And then it's a secondary question. It's like, okay, what's the right way to get there, right? And the latter one is good for educational researchers, experimental psychologists. They're very good at figuring out how skills transfer and so on. But as mathematicians, our job, so we should also be thinking about what is it that we want students to be getting out of these classes? What is it that we want them to convey? Um, and so yeah, it's yes, that's all I have to say there.
I also want to. I want to follow up what Jacob said because I agree with his points, and I think I worry. Uh, I would say that that's why I don't worry so much necessarily about the educational issues because I think it's something, but it is something I do think we do need to spend time on because I think Jacob described the answer to the. So there is a challenge, and Jacob's not worried because the answer is clear to him, and I think the answer he proposed is the right one, which is he has a midterm and he incentivizes students to in his classes they're going to be incentivized to understand the material and how they understand it best is up to them and they'll learn how to understand it best. And so I think unlike some other subjects where things are trickier, we do have good proxies to help check whether there's understanding, and we just should just take care in our classes and similarly for grad school and at every stage of the pipeline to make sure we incentivize students to do the things as Jeremy said. What do we want them to know? And we incentivize to actually learn it. And that may involve, as always with math, we're used to proxies. We give tests for an hour. We want to test long, hard thinking, but we give tests that last a small amount of time and they're proxies. So we do need to spend some time. And I worry about things like other subjects, such as it's really important to write an essay, to write a long argument. And that's something that's hard to have a short proxy for on a test. So other subjects have to suffer. Computer science, I don't really know. I worry about them, but that's their problem. But I think it's something that we have to, right. So I agree with Jacob, but I think this is something we have to take care in our classes, and there's a slippage where we're comfortable with letting students cheat or not have that understanding and still give them the A in some places. And I think that we should have a hard line to make sure we know what we want them to do and incentivize them to do so.
I mean, so do each of you have a hard line of what you'd like an undergraduate to know? I mean, Jeremy earlier, this seems less essential than it might have been before. So what for you is the bottom line of what you want an undergraduate to know?
Well, I'll start by saying I don't know. I don't know. Like I said, I don't know exactly how she. I mean, there's one argument that says, look, we don't really have to, teach our students to do integration by parts because any computer algebra system and AI system can do it. The counter argument is, look, we still teach kids to, do arithmetic, even though they can use calculators as part of building the intuitions. In the same way, in a calculus class, just understanding what the concepts mean, and even if we're going to use AI later on, understanding just how to use the concepts. I tend to think that the second is the case, that we do want to teach calculus roughly the way we've been doing it. It's as a way of building up the intuitions and so on. But I'm not sure. I think it's something we should be talking about.
Yeah. I mean, I think undergraduates broadly should be able to reason about abstract structures and make cogent arguments by the time they graduate, right? I mean, there's several different sort of areas of mathematics that they'll have the opportunity to do that in, and that might change, but we and maybe it becomes something that is less akin to engineering and more akin to humanities again, right? Where mathematics fits on that spectrum, but um, an undergraduate is not just able to use engineering tools, but is able to themselves think, right? And think mathematically. And that's not a very precise, learning outcomes for my accreditation visit. But it's still, I think that's not going to change, right? I mean, if you think about calculators or other types of technologies that help us do things that we haven't been able to do before, whether it be lift up heavy things or drive them far across the country or whatever. We don't do those with our bodies, but we still want our bodies to be fit and strong. That's important to us, and we still want our minds to be able to think. Um, I think, coming back to one of the early concerns Jeremy mentioned about access, I mean, I also worry about increasing inequality because I think that you're going to see people who education, I think, could become a luxury good again.
I just want to add that in the teaching conversation, I think it's important to separate the certification that we use to then select students in the basis of meritocracy and the teaching process. I think a very unhealthy part of our current ecosystem is that we are both the teachers and the testers. And I think this creates very bad incentives that you can see play out. So in terms of certification, like if because we are at the moment we are in the meritocracy, we want to know who the competent, the best students are or whatever for whatever purpose. Then we should put in some thought into how we test, what actually comes up. But on the basis of teaching, I think the teachers should be fully encouraging the students to use all the tools available, with the understanding that then the certification tests the final result, and the weeding out will sort of naturally happen.
Yeah. Ravi, do you want to add anything to that? Or?
Sure. I guess the question as to whether what we teach will be different. I think some might describe. I think people can see the same thing and describe it differently. And I would say it's evolution, not revolution. I think what we want in people to know remains. I mean, when calculators, I think it's always a somewhat poor analogy to bring up calculators, but I think but there's something there that we want. With calculators, we know people say, why do people need number sense? Because they can always ask a calculator, but they don't bring a calculator to the grocery store. When deciding what to buy, they don't bring a calculator. And things like understanding exponential growth or adding fractions, then we have to vote and think about pandemics, and we have to think about applying for mortgages, and there are all sorts of things and it is an issue where the people who are if you want, it's an equity issue too. People who are education becomes a luxury good, and then people in certain zip codes will do much better, and people in other zip codes will do much worse. But I think things will naturally change. But we should, again, I think we should. If you don't want a math degree, you shouldn't get a math degree. But if you want a math degree, it's going to mean something that's going to evolve slightly. But the evolution feels very natural because it's the same. There's a certain kind of thinking you may want in this degree. And for example, an important change that seems very reasonable to me is historically we require people to take calculus before linear algebra. I'm not sure intellectually what the case is for that, but I could imagine that perhaps people could learn linear algebra, and some linear algebraic thinking will be very important for all sorts of, not every single citizen, but people in all sorts of fields. So I think things will change, but it's reasonable. It's not like the world isn't falling apart, or it's not completely changing in a way we have to rip up all our old books and write everything in.
Well, thanks. Jennifer, did you want to say something about publishing? Or anyone else? Like, what would you like to see change with
I mean,
publishing?
well, I don't think I have the answers for that. I do think that that there need to be guidelines about disclosure of AI use, and by both authors, editors, referees, and protocols. I'd love to see like standardized prompts even, that people could, I mean, maybe that's a bad idea, but that you could use to say, summarize your, interactions with the model, or if I'm getting a paper in for a referee, evaluation, and maybe there's a standardized prompt that journal has me use with my choice of model to get a summary of the paper to start digging in, or there's also questions to me about, if this is an unpublished paper, should I even be using a frontier model on this, right? That seems to be breaking rules about copyright. Sometimes like we have a local open weight model that we can use for inference that's pretty good at our institution, but not everyone has access to those things. I do worry about, I think formal verification could be a really useful tool for publishing, but I also worry about the changes in incentives, right? If it's expected that you're going to formally verify papers in order to get them out, does that disincentivize especially younger people from trying out brand new constructions that don't already have like a good foothold in MathLib, right? I mean, how does this change what people are working on? I don't know what the answers to those questions are, but I would love to see us as a community, again, like I said, maybe pilot some things, try some things, see what the effects are, and maybe with some soft policies, right? Like this is what we're encouraging people to do, not necessarily hard policies, and then evaluate and iterate. But I think it's a challenging question because journals are not just about communication. They're also about like, proving your worth and getting your job and getting your promotion. And whether they should be the thing that is so important for that is another question, but they are. And so these decisions matter.
Yeah, does anyone want to add to that?
I think these are all great questions. I also worry about the fact that now, I mean, again, with AI, it's just becoming so much easier to churn out papers. I mean, editors have this problem of just dealing. I mean, editors are already overwhelmed. I think the situation is going to just get worse.
Yeah. Well, one last question before we go to the audience questions. When do you think the first major theorem that you care about will be proved by AI? The Riemann hypothesis, the BSD conjecture, or is that unlikely to happen? Do you think this will be before 2040?
Hey, I'll disagree. I feel like I'm going to disagree with the premise of the question. Like I feel like I don't understand. I mean, or if you want, I can take it literally and very soon, or maybe it's already happened, or almost instantaneously. But okay, well, maybe I'll just leave it there. I'll come back and say more in a little bit after. I think Jacob is going to say something that will
I
perhaps
was just
disagree with me.
curious what you meant by. I was just curious to hear more about what you were saying. Actually, if I couldn't understand.
Okay, sure. Maybe I'll say a little bit more. I feel like a lot of the discussion is often being comparing, in essence, AI models as one shot solutions of problems versus humans working independent, not using AIs at all. And this seems like a very strange competition to me and not relevant. And I think we talk about it because that's what social media and tech billionaires talk about on their tweets. I don't know why but the really interesting thing to me is what's advancing mathematics. And I think what is advancing mathematics are models and humans currently working together. We can argue that fairly soon, whether or not soon humans will be out of the loop or not. But right now, I think the really exciting theorems are going to be proved often by humans using models. And I think it's a slippery slope as to what you count, because because already by any reasonable measure, fantastic theorems are done with the assistance of AI, because people are thinking hard about things, and in the course of their thinking, they use AI. And at what point does it become a substantive help? It's an interesting thing to have a one-shot question where with no human, you just give it the question. But to me, it's a somewhat dry, sterile thing. Like the really exciting things are often where humans, where I know, and I notice that the best results are always done. Everyone that I know about so far has been done by people who have some domain expertise have been involved, and then the models have been spectacular. No, okay. There's some exceptions. Maybe I shouldn't make such a strong statement, but to me, the interesting thing is, like, when will the first Fields medal level conjecture happen? I think in 2026, maybe we'll see Fields medalists will say that they are AI influenced already. 2030, safe bet. And so I just don't see why a company and the top firms are going to, you get the best models that are out there that are most likely to do this. Those firms are incentivized to do things with humans because to make the biggest splash, they want to prove the biggest theorems. The ones trying to prove Navier-Stokes are doing it along with domain experts. And of course they are, because they want the biggest result. They want to use all the tools at their disposal. So the right thing seems to be something about the combination of like how serious AI is being used. But then it's a somewhat imprecise question.
So if I can, I can answer your question, I think. I understand your concerns, but I can answer your question as to why people are focusing on one-shot questions. And it's because there's a lot of discussion right now and anxiety around, do humans have a special ingredient, a secret sauce that the AIs don't, such that the AIs need humans in order to do mathematics? And that's a more or less empirical question. And the answer to that question is in fact important for like young mathematicians in particular, who like looking for jobs, and other mathematicians as well, like for the future of our field, knowing that while it is in some sense that you're pointing to an artificial question, it does in fact, like, if in like 2 months I can type in, hey, is the Hodge conjecture true? And the AI is like, oh yeah, sure, just integrate this and here's a modular form and there you go. Then the arguments of like, well, the AIs, can do here and this bits on the edges, but they still need humans for putting it all together or theory building or whatever, disappear. And the world becomes much clearer. So I think the question is more about deciding what kind of world we're in. Given that, I think 2040 is no one has a crystal ball, and like I'm going to say numbers so I can look silly. I think 2040 is ludicrously far in the future for this question. I would be fairly shocked, excuse me, if by 2030 we do not have AIs one-shotting, I don't know, Fields medal level results. I mean, I don't know how you want to quantifying it is hard, like Ravi said, and that becomes a little pointless, but like results that are no longer debatable as to like their top math level significance.
One interesting thing for me in writing the questions for this panel is I came up with 10 questions myself, and I asked Gemini to come up with 10 questions, and then I asked the panel to choose which questions they wanted to answer, and the Gemini questions got a lot of negative reactions from this panel. So I don't know what you take away from that. Okay, well, there are a lot of things in the chat. So I wonder, is there someone who feels like they would really like to ask a question and we haven't covered what you would like to talk about?
You're prompting the audience right now, right? Not
The
us.
audience, yeah.
Yeah, first of all, thanks a lot for holding this panel, which is very timely. And also, I mean, it doesn't have to be the be all and end all. I mean, we should keep these discussions reoccurringly. Now, my main question is, would we solve this big kind of like meandering and convoluted problems that rise up with the use of AI and with technology in general, but AI is unique in its impact on humanity and of course mathematics, by returning to analog assessment. I'm not saying we can use AI, everybody can use AI, like we could use dictionaries, encyclopedias, books, what have you. All these are more rudimentary forms of AI. So we shouldn't fret at the idea of using AI, but a human must be assessed and prove its human, whatever it's in here. And do you think that would be a sufficient solution to actually kind of like helping us from flowing and falling into tangents of what AI is, what's the impact on cognition, understanding, parsing, etc. That's my question.
I think short term, that's a great solution. Is humans? Sorry, Rachel. Maybe I spoke.
No, go ahead. Go ahead.
I think short term, that's a great solution. Is just like sit a human down with a piece of paper and a pen and like a problem and have them go or whatever. I think longer term it's less clear. If we're in the world where centaurs really are the prevailing usage of AI, which I don't think we're in. I think I made that clear, but we might be. Assuming that is the case, you can't really test a computer scientist without a computer. And at some point, it becomes almost pointless testing them without a debugging system because they have a debugging system. What you really want to know is can you do your job well? And so typically you have like computer scientists write code and they have a debugger there and they have a terminal there and they can use that. And only requiring computer scientists to work with a piece of paper and pen it becomes counterproductive. I think the same thing might happen in math. I don't think we're there yet, but I think we shouldn't rule out assessments that involve AI systems as well to a limited capacity.
Mhm. So there was another remark in the chat that all these assessments are much easier in smaller classes, but because of budgetary constraints, we're in a situation where many classes are very large. And I wonder if you have any thoughts about that.
So here we might reasonably expect some happy results as well. I mean, with large classes, we already have this issue that we have multiple choice tests as for decades as proxies, and they're very non-ideal proxies. We're never happy about giving tests that are just multiple choice, and the students are not happy. You can imagine it's not hard to imagine, unlike some things which feel like they require several steps, where you can have different kinds of things that can be graded at scale by an AI. So students are in class on paper writing something, and then they just get and the first pass is done by at least the first pass is done by an AI, and it's imperfect, but better than multiple choice tests. So I feel like the situation can't get worse than it currently is, and it can only get better. And it's of course far from perfect. If you have 1,000-person class, you're just not going to get enough human beings to grade that 1,000 problem sets at scale.
This is another place where I think there's a lot of opportunity for experimentation and innovation. I mean, people have talked about standards-based grading for a long time. It's maybe a place to think about integrating that, especially if you have in-class artifacts that you can say, this person has demonstrated this standard so many times here. And so then maybe at the end of the class, you have 500 people, but you only need to do interviews with like 20 of them to get the final assessment on whether they've met the standards or something.
Mhm.
But it is a hard question, just why we have such large classes in the first place. I mean, maybe this is also going to change. We have a changing demographics coming along and also changing attitudes toward higher ed. So it may be that we look back wistfully on this problem of too many students in the near future.
Mhm. Thanks. Let's see. Any other Alice, Helen, would you like to ask your question?
Hi, I don't know if my audio works on my computer. Can you hear me?
Yeah, it
We
works.
can.
So maybe this question is especially for Jacob, but I'd also like to hear what the other panelists have to say. But so if we're going to think big and we think things should really change, what should the future look like? So are universities still going to exist, or should it be replaced by something else? And how do you envision that? Also, what are the mathematicians of the future going to be? Will there be mathematicians? Will the mathematicians or the AI?
I don't know is the main answer. And I'm not, it's very hard to predict the future. And I'm, to be honest, like not the best at thinking of coming up with social structures that are stable and work. So I don't know in like a strong sense. I both don't know. I don't know which skills are required to figure it out. And whatever they are, I suspect I'm not the best person at those skills. Having said that, I do think the future looks more like a somewhere between math is practiced as a hobby and a social club. I do think professional mathematicians are not a sustainable career for the future. It's not clear if any form of like economic labor will matter in the future. And I don't know what that looks like either. So in the medium term, I think math becomes something like a social club or like hobby, somewhere between those two. In the longer term, I think we have to grapple with the question of how do we organize our society in a world where human economic labor no longer matters. This still sounds like sci-fi. Like this, we're in a sci-fi world, right? Our current world is sci-fi from 5 years ago. Even within our current world, what I'm saying now is sci-fi coded.
Mhm.
So people have doubts, and they should. This is my best guess at what's going to happen. I do think it's important to play the part of Ravi for a second, even though I believe this is true, that like within decades we'll have to grapple with this question. I think it's important to get to that future by keeping humans involved economically in the medium term. So I think what I think like in the medium term involves is some kind of like AI does the math and human mathematicians sort of interpret it and discuss it and try to stay in the loop and try to make decisions where we still have to make them. And then in the longer term to figure out how we exist in a world where we no longer offer economic value.
Wow, that's
I,
bleak.
I'd like to give a more optimistic view. Well, so first of all, as the question of whether universities will continue to exist, I mean, I hope so. I think that, something about bringing young people together and bringing people together to exchange ideas and interact. I'd hate to imagine a world or society, without that. I have tremendous faith in mathematics. It's been around for centuries, and I think there's fundamentally it's about interacting with one another with language that's precise, reasoning in precise ways, reasoning in ways that give us means to come to consensus about the answers and the decisions we make and what they mean, and coming up with answers that are stable over time. I think there are just evolutionary, culturally, there are things that are very fundamental to mathematics that just aren't going to go away. Um, I do think that, as Jacob says, a lot of the particulars about what it means to do mathematics will change, and they have changed over the centuries. I mean, what it means to do mathematics has changed and will continue to change. Um, um, in some ways, so I always like to emphasize that we should only care about AI insofar as it's useful to us, right? It's, us at the end of the day, it's us making sense of the world, making sense of our experience, interacting with one another, making decisions. And, mathematics is there to help us do that. Not exclusively, but it's one component in interacting with others and making decisions and coming to consensus, and, making predictions and deciding what we want to do. I don't see that role going away. I see, maybe AI again is good at proving theorems and filling details. We still have to decide how to use it, and I think whatever mathematics becomes, it's going to be part of it is going to be figuring out how we're going to use the technologies to further our ends.
Helen, would you like to ask a question?
Yeah, you kind of led directly into it here. I had to one point deal with a Brown undergraduate math major who was really stuck because she didn't see, if she didn't want to particularly go on to graduate school in math, is there any reason to be a math major? And I think this is something that's really affecting a lot of students. I know computer science enrollments are dropping, and I think math ones might also. And we may all love university mathematics, but if we don't have the students to teach, we might not have that luxury. But I'm kind of not sure how to respond to the student. I mean, really, if we've got AI doing all sorts of things that people used to do, is there really a good reason to get a math major? And yeah, we like to believe we teach them to think they can do anything, but sell the math major.
Okay,
Yeah,
so,
I
okay,
think this is a,
this one I want to. Sorry.
no,
Yeah,
it's
go ahead,
okay.
Ravi.
Go for it, Ravi.
Okay, so this one's like a an easy one right across home plate. This is a but I should say come right out and say that there are different points of view, and I'm fully on the teaching how to think. Some people disbelieve, think of the math major as something different, and if you do, I disagree. I'm gonna that's not my math major. So at this point, in this new world, at Stanford, math is now the number 5 biggest major in the university. At MIT, I believe it's number 2 right now. Is that right? Right. At Chicago, it's been recently number 3. And our students, and I think those people who think of the math major as the point of a math major is to get a PhD and become a math professor, I think have always been deeply misled. And I strongly disagree. That's not the point of view. That's not the purpose of. So I guess I have a strong disagreement. And my kind of math major is kicking the butt of your kind of math major because I have hundreds of them, and they're going out and conquer. And the current world is currently being made by my kind of math major. So my kind of math majors are founding a.
Do not confuse what I'm asking about with my kind of math major.
Oh no, I'm not. So I'm not speaking. I'm not saying Helen. No. I should say I know outright that I agree with Helen I'm speaking not to Helen, but to my putative. No, Helen. I know I agree with because I've known Helen for a long time. So Helen's kind of math major is my kind of math major. But it's an easy sell, and the disappointing thing is that at the same time, math programs are being shut down, and I think there's no statistics department in Nebraska anymore. They shut down so this is something where those with more social capital, those at wealthier universities, know the importance of this kind of thinking, and those at the same time as we reduce the amount of mathematics available in lower funded school districts, so math at least at this moment in time has an extremely bright is an extremely wise thing to do, and it has been for decades, and it's possible it's possible this will change. One thing I like, Jacob made a bunch of good points, one of which is that if there could be vast disruption coming, but his example of vast disruption coming to the career of mathematicians was contingent or concomitant with mass disruption across economically. He said it right, and he's nodding his head right. So it isn't that math is useless and everything else is useful. So if the rest of the world goes to pot, then we are indeed at risk. But the way things currently are, this is the golden age. This is the time when we have the biggest, most successful, financially successful. You could argue whether people, morally successful. I won't argue that. So I feel like this is a softball. It's really easy to sell a math major right now, which is why we're getting more and more and more.
Yeah, I mean, I guess I was just going to say something that this concern of your students is not just a concern of math students, right? I have a daughter that's finishing up her junior year this year, and she's got lots of things she's interested in, but most of the things that really excite her are creative. And she just doesn't see that those things are careers anymore. It's very hard to think about what to study. I think that this is going to be a question that our students will have. And this comes back to what I was saying about education to some extent becoming a luxury good, right? I mean, we work out to keep our bodies fit. We do other things to make ourselves feel good. Being able to understand things feels good. We want to be intellectually developed humans. And I think that will stay in demand, but it may be that it is more and more an elite thing. I mean, the argument that we need mass numbers of people to have these skills when we have technological tools that can do them is something we need to think about. And I don't know what that's going to look like exactly, but I do worry about just the increasing inequality on top of the economic inequality that we already have, cognitive inequality.
So I'd also let me again try to inject a note of optimism. Over the last couple of decades, in terms of majors, we've seen majors shift. Computer science, business, statistics; those have grown a lot. At the expense of the humanities that have been shrinking for a long time now. I expect that now in the age of AI, we're going to start to see the pendulum shift back to the humanities a little bit. We have students that come out with these technical skills, but are unhappy. We can do more than we used to be able to do, but we don't know what we want to do, and people are unsatisfied. So I do think the humanities will become more important in our lives going forward. And I'd also like to say I think mathematics comes out well in that sense. I like to say that, mathematics is the only discipline that's simultaneously, a science, an art, and a humanity. I mean, it's a science. It gives us the basis for science and technology and our scientific discoveries. It's an art in that there's this deeply aesthetic component to it. But I think it's also one of the humanities. It's how we make sense of the world. It's we're very when we do mathematics, we're very mindful of this long 2,000-year-old history. It's about how we make sense of the world, how we abstract. We're thrown into this noisy, messy, crazy world, and we try to make sense of it. And part of what we do is we use language, we come up with ideas, we try to be precise about it. It's about the human experience. And so,
Well,
yeah.
that's a great sentence to end on. And so I want to thank everyone for joining us today. I mean, it's clear there's a lot of things that people want to talk about. This is the largest audience we've had at VaNTAGe for since the pandemic. And so I want to thank again these panelists for taking the time to share their experiences and thoughts with us, and thank all of you for coming here today.
Rachel, can I make one more comment? I know we're
Yeah.
ending, and I'm so sorry
Okay. All right.
to push. I just want to.
All right.
I would just like to very briefly try and reject the label of Mr. Pessimism, and
Okay. Okay.
I'm happy to get the label of Mr. Bullish on AI and Mr. Sci-Fi and Mr. Wonky Man. Those are all fine, but the future I described, where we have no economic value, is not necessarily a bad one. I mean, I love doing a lot of things that don't produce value to the world. Like
Mhm.
I'm not nearly, not just not the best, but not even competent professionally at music, at improv comedy, at sports, at like a lot of things that I do that are a lot of fun for me. And some of my most joyful times doing math were doing math contests in undergrad, where I was just learning math and producing nothing new. So this world where we don't produce anything new does not mean we don't have human connection, we don't have meaning, intellectual stimulus. I think there's a lot to potentially enjoy about the world that I describe. So I just wanted to say that, and I'm sorry for taking up the
No, no,
time.
I'm glad you added that comment. So yeah, again, I want to say I really learned a lot from listening to the four of you today, and it gave me a lot to think about. So um, best of luck to all of you finishing off this semester, and we'll see you again at VaNTAGe in August or September.